Good day everyone. You have learnt how to find the equation of the plane passing through one point and two perpendicular planes. Now let us see how to find the equation of a plane passing through 2 points and one perpendicular plane. Okay. First let us write the general equation. Let the equation of the plane be. This is what we are going to find. Let the equation of the plane be a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. You know here x1, y1, z1 is the point through which the plane passes, and a comma b comma c are the direction ratios of the normal to the plane. Now this plane passes through the point. We can take one. Okay, this plane passes through. Let me take one point 3, 4, 2. So you substitute this point in the place of x1, y1 and z1. So we will get a into x minus 3 plus b into y minus 4 plus c into z minus 2 is equal to 0. Mark this as equation 1. Now this plane 1 passes through the other point also. Plane 1 passes through, you write the second point now, that is 7, 0, 6. Now you substitute it in the place of x, y, z. Okay, the first point in the place of x1, y1, z1, the second point in the place of x, y, z. So now you will get a into 7 minus 3 plus b into 0 minus 4 plus c into 6 minus 2 is equal to 0. That gives you 4a minus 4b plus 4c is equal to 0. 4 is common, you take it out. So a minus b plus c is equal to 0. Mark it as equation 2. Now it is given the plane 1 is perpendicular to that plane. So let me write that. That is plane 1 is perpendicular to the plane 2x minus 5y is equal to 15. You know when two planes are perpendicular, their normals are perpendicular. And when two normals are perpendicular, the sum of the product of the drs is equal to 0, right? That concept we are going to use now. The planes are perpendicular, therefore normals are also perpendicular. So sum of the product of the drs of the normals, right? Drs is equal to 0. So now let us write drs of normal to plane 1. Drs of the normal to plane 1 are a, b, c. Let us write drs of normal to the given plane, that is that 2x minus 5y is equal to 15. That will be 2, minus 5, 0. Now let us use the sum of the product of the drs. That gives me 2a minus 5b, that is equal to 0. Let me mark this as equation 3. So the equation 2 and equation 3 are containing some a, b, c, that is 3 unknowns. We have to use the rule of cross multiplication now. So a, b, c, again a, b. Hope you remember this. So first take this equation 1 minus 1, 1, 1 minus 1. Now 2 minus 5, 0, 2 minus 5. So now you will get a by, take these 2, you will get 0 minus of minus 5. Then b by, you will get 1 into 2 is 2, right? Now c by minus 5 plus 2. So that gives you a by 5 is equal to b by 2, that is equal to c by minus 3. Equate that to some constant of proportionality k. So you will get now a is equal to 5k, b is equal to 2k, c is equal to minus 3k. Substitute these values in equation 1 now. You will get 5k into x minus 3 plus 2k into y minus 4 minus 3k into z minus 2, that is equal to 0. K is common and you have a 0 there, so cut the K. So you will be getting 5x minus 15 plus 2y minus 8 minus 3z plus 6 is equal to 0. That gives you 5x plus 2y minus 3z. Collect the number terms, you will be getting minus 17. That is equal to 0, and this is the Cartesian equation of the required plane. It's better to write the vector equation. So we can write the vector equation is r vector dot 5i cap plus 2j cap minus 3k cap minus 17, that is equal to 0. So you have got the Cartesian, you have got the vector. Hope you understand this model. Now you have already learnt equation of the plane passing through one point and perpendicular to two planes. Now you have learnt equation of the plane passing through 2 points and perpendicular to a plane. They can either give perpendicular planes or they can give parallel lines. The concept will be the same. Now the easiest model will be, supposing they give you 3 points and ask you to find the equation of your plane passing through the 3 non-collinear points. If you know the formula, that itself is enough and you can yourself work. So the equation of the plane passing through 3 non-collinear points, you have to have a determinant. Okay, you will get x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1, that is equal to 0. So they give you 3 points. Take the first point as x1, y1, z1. The second point as x2, y2, z2. The third point as x3, y3, z3. Just substitute, expand the determinant, you will be getting the equation of the plane. That is so simple, so that doesn't need any explanation or example, some I think. So now these 3 are some basic models you can take. So these you should know. Hope you have understood these things clearly. Now thanks for watching the video and subscribe to the channel and click the bell icon to get further notifications.